Hi everyone, welcome to another free mobile tutoring lesson. So this will be a basic lesson, so especially for beginners and those who don't have professional level tools like DC power supply and all that stuff that you use to easily do troubleshooting of the mobile phones. In this video, you will learn the basics of troubleshooting the mobile phones, where you need to start from understanding the primary circuit of the mobile phone and the secondary circuit. So I'm just going to go straight to the point. Like I said, I have videos about this and I have courses that if you want to learn everything from the basic to the professional level, micro soldering level, you can get my courses from the link in the description or on my bio if in case you're watching this on TikTok. So when you get a phone that it's not powering on, you open the phone. First, you have to locate the battery connector of that mobile phone. You need to understand the VBAT circuit of that mobile phone. The VBAT is the battery positive line of that mobile phone. You need to understand the VBAT circuit of that mobile phone, and I'm just going to make that clear to you. From the battery connector, the VBAT voltage comes in from the battery when you connect the battery to the PCB. So in this jumper point here, this is the VBAT jumper point, which means that if you connect your battery to this mobile phone and test here, you will get a 3.7 volt. You will get the exact voltage that is in the battery. You understand? And that's the main input of this mobile phone. So from here, where does the voltage go to? The voltage goes to the power manager IC or the charging IC, depending on that mobile PCB. Keep that in mind. I'm going to show you what I'm talking about. So in this mobile phone, thank God we have our PCB guideline right here that will show every line so that you can understand clearly while I explain. So if you check the red line, you will see that this is our VBAT line, right? Which means that from the battery voltage, when you connect the battery to the phone, the VBAT voltage goes to this IC. I'm going to explain this, don't get confused. This line that comes in from this section, this is the VBAT line. The VBAT voltage coming directly from the battery. It gets to this capacitor and it gets to this IC. So this IC is the charging IC of this mobile phone. So this mobile phone that we're looking at right here, it's a Techno mobile phone. But keep in mind, some of these phones, some of these PCB guidelines will show the charging IC. But if you look at the mobile PCB that you're having, you won't see the charging IC, but you will see the section of the charging IC. But when you don't see the charging IC, you need to keep in mind that the VBAT line goes straight to the power manager IC. Just like in some models, any mobile phone that doesn't have a big charging IC doesn't convert the primary voltage, which is the VBAT, to the secondary voltage, which is the VPH. But in this mobile PCB, for some reasons, we have the VBAT input and we have the VBAT output. So this VBAT output is the secondary voltage of this mobile PCB, and this is the power supply of the power manager IC. This is the voltage that goes to the power manager IC for you to be able to switch on the power manager IC and start the voltage distribution to other parts of the mobile phone. So keep that in mind. There is one important point in which you need to look at. So you can see we have the VBAT input, like I said, it's the charging IC, and from here you can see that we have this output, which is known as the VBAT. You will see this as the VPH in most mobile phones, or the VSYS in most mobile phones. But just keep in mind that this output right here, you will always see this coil, which is known as the VPH coil. You will always see it. This coil right here is the output voltage of the VBAT line, which is converted from the VBAT to the VPH, but known as the VBAT. Right here, you can call it the secondary VBAT. This line supplies power to the power manager IC, which means if you get the VBAT voltage in this capacitor and you don't get any voltage In this inductor, when you connect the battery, it means this charging IC is bad and needs to be replaced. Keep that in mind. So when the output voltage, the secondary output voltage, comes out through the inductor, where does it go to? Like I said, it supplies the power manager IC. It gets to the power manager IC. You are not going to see that right here except you use schematic diagram. But like I said, this is the basics. You don't want me to go deep into advanced lessons right here, and you will get more confused. I have everything, a lot of videos, and you can always check the videos. Okay, so now that you know that in some mobile phones, the VBAT voltage leaves the battery connector to the charging IC or directly to the power manager IC. How can you check if all of these circuits are okay? First, for you to confirm if the power supply section of the mobile phone is okay, you have to check the power on voltage in the power switch. You understand? Which means that if you connect your battery right here, you see that the VBAT voltage is here, which means that there is actually voltage in the battery. Or you go to the charging circuit, if in case the charging circuit is a big circuit like this one, you can see a big charging IC, and you get the VBAT voltage in this capacitor. What next you will have to check? You will have to check the power key, if there is any voltage in the power key. If there is voltage in the power key, that means that the secondary to the primary, to the secondary circuit is okay, which means that the charging circuit is okay if in case it uses a big charging IC. But if it doesn't have a big charging IC, it means that the same primary to secondary circuit is okay in the power manager IC. You understand? But if you don't get a voltage, you need to replace or revolve the charging IC. That's if you have checked. And you see that we have the input VBAT and we don't have the output VBAT or the VPH. You understand? So in most cases, the charging IC will be bad and you will need to replace. But in some cases, you just have to reball, which is because of an open circuit. That's why reballing will solve the problem. Another way to check if the charging circuit of the mobile phone is okay when troubleshooting that mobile phone, because if the charging circuit is not okay in some parts, the phone might be able to switch on, but in some cases the phone might not be able to switch on, depending on which particular circuit in the integrated chip is bad. You understand? So to check if the charging circuit is okay, another easy way to check is to connect the charger to the phone. Connect the charger to the phone and disconnect the battery of the phone. Set your multimeter to DC range. I'm going to show you my multimeter and show you DC range. Maybe you don't know what I'm talking about. So you have to set your multimeter to DC range. So this is my DC range right here. I don't know if you are seeing that. DC range, you can set it to DC 200 or 20. That's still okay. When you set your multimeter to DC range, connect the phone on charge, you are going to find the charging voltage in the battery connector. If you don't get the charging voltage in the battery connector, that means that the charging circuit is not okay. You understand? The charging circuit is not okay. Or if there is no charging circuit, because there are actually phones with no charging circuit. If the charging circuit is not okay, which means that the charging circuit is integrated with the power manager IC, that means that you will have to revolve the power manager IC or change the power manager IC. So if you want my courses, you can get my courses right now with a 45% discount. That's a huge discount, both the basic and the professional level course. You can check the link in the video description, pin comment, or check my bio if in case you are watching this on TikTok. So follow, subscribe for more amazing videos. So thank you and see you soon.